Okay, welcome to Chapter 3, Solving Linear Equations. So in this chapter, the basic idea is we're going to be solving a bunch of different types of equations. Some one-step, some two-step, some multi-step equations with variables on both sides. You're going to get a lot of work on solving equations. And pay attention during the lessons because I'm going to be demonstrating to you what your work should look like. A lot of you have, solved equations before. You've been doing this since 4th and 5th grade. It's not really anything new, but we are going to be taking it to the next level eventually. So I want your work to look really, really good. All of the equations in this chapter are linear equations. Linear just means line. So if we were to graph these guys on the coordinate plane, they would all make lines. Okay, so our first section is 3.1, solving equations with addition and subtraction. So to isolate the variable in all of these equations tonight, you're either going to be adding something or subtracting something with a couple tricks involved here and there. Okay, equations can be thought of much like a balance. Equations can be rewritten using transformations so long as whatever is done to one side of the equation is done to the other. It's a very important principle. This will keep the equation in balance. The result is what we call an equivalent equation. Okay, so for example, this is a linear equation, x minus 3 equals 14, and the goal here is to try to get x by itself. Now, most of us can do this in mental math, right? What number minus 3 is 14? We know that the number is going to be 17. But there's also this process of working backwards to get x by itself. That way, when the numbers aren't so nice, we can rely on the process. So what do we do from here? How do we get the x by itself? Well, you'll remember we're going to add 3 to both sides. And once we add 3 to both sides, that negative 3 and positive 3 on the left are going to cancel out, and the 14 plus 3 will make a 17. So we end up getting x equals 17. Now, believe it or not, I don't want your work to really look like this. I mean, I want you to do these steps, but there are a couple things I have issue with. First thing, notice that those equal signs, the one in the original equation and the one in the equivalent equation that you get at the end, the x equals 17, they're not lined up. Solving equations, it's a lot like writing essays. There's a format to it, there are certain rules to it, and you want it to look good. So I will expect all my students to have those equal signs lined up. I do like how they added 3 to both sides. That part is important. Okay, so if I had to go through this and show you what I'm talking about, this is how I will expect your work to look. You'll begin by adding the 3 to the left and also adding the 3 to the right, just like they did. Okay, now negative 3 and positive 3 kind of cancel out. They make a 0, so you're left with x on the left, equal signs lined up, and then 14 plus 3 is 17. So it's really important to have these equal signs in line because eventually we'll be doing 7-step, 8-step equations, and I'll want you to have this organized that way. It just looks better, and it's also easier to find where you make mistakes. We're not done. You should always check your work. Nice thing about solving equations, you can know if you have the right answer or not. So you can go ahead and circle this guy like it's your final answer. But you do need to check them. So take the 17 and plug him back in mentally. Okay? Does 17 minus 13 equal 14? Yes. You can write that little check mark there. That check mark tells me that you have actually mentally checked your work and you know that it's right. Okay? That's an important step. Okay, let's go ahead and move on. Inverse operations are operations that undo each other. Addition and subtraction would be a good example of inverse operations. Also multiplication and divisions, they sort of undo each other. So we use inverse operations to isolate the variable. And they give you this example here of x minus 9 equals negative 17. Okay, so we have the x and the negative 9 on the left side and the negative 17 on the right side. And how do we get the x by itself? Well, if you were doing work on this, you would add 9 to both sides. And that's what I would expect to see on your paper. Okay, the negative 9 and the positive 9 would cancel out. And then the negative 17 plus 9, notice that that's a war problem. The negatives win, and they win by negative 8. So that's how we're getting x equals negative 8 down here. Once again, you're going to want to check your work. So you take that negative 8 and you mentally plug it in all the way back up here for x. Negative 8 minus 9. Well, that's a get mug twice. You lose 8, you lose 9. You have lost 17, so that matches up. So just make sure that you are always checking your work. Sometimes it is necessary to simplify an equation before you perform the inverse operations. So just like we added 9 to get rid of negative 9, that's an inverse operation, but sometimes there's a little pre-work to do before you get there. So take a look at this guy. Negative 11 plus 4 equals n minus negative 2. Okay? There's a lot of stuff going on here, and some of that stuff can be simplified. So I don't want to start, adding 11 or subtracting 4 or adding or subtracting 2 until I really have this in much simpler terms. Okay, so what can be simplified right now? Well, if you look at negative 11 and positive 4, I can combine those like terms right now. If you can combine like terms, you should always combine like terms. It's going to simplify everything. So negative 11 plus 4, that looks like it's going to be negative 7. Once again, keep those equal signs lined up. Okay, now n minus negative 2. That's not simplified either. We all know that we can take minus a negative and convert it to what? Well, minus a negative turns into a plus. So n minus negative 2 is just a fancy way of saying n plus 2. And so those are the first steps that you want to take. Now, this is much more simplified, and here's where I can use inverse operations. Do I want to add 7 or do I want to take away 2? Well, remember, the focus is on the n, right? We're trying to get the n by itself. So we will take away 2 from both sides. So 2 and negative 2 kind of cancel out, and you're left with negative 9 equals n. Now we might want to go back in and check that, remember. So take the negative 9, plug it back in up here for n. Negative 9 minus negative 2, that's going to be negative 9 plus 2. That gives me negative 7. And that negative 7 matches up with what we get when we do a negative 11 plus 4. So negative 7 does equal negative 7. That means I have the right answer for n. Okay, so that's the process you would go through. You want to simplify, combine like terms first, and then you can worry about performing inverse operations. All right, very good. Let's go ahead and move on to something else. Okay, a linear equation is an equation where the variable is raised to the first power and does not occur in the denominator, inside a square root symbol, or inside absolute value symbol. So how do we determine whether or not something is linear? Well, the easiest, not the easiest way, one way is to graph it. If it makes a line, it's linear, but that takes time. Okay, you should be able to look at an equation and know whether or not it is linear. So I'm going to throw up some equations here, and I want you to think about why it's linear or why it's not linear according to the definition above. Let's take a look at that first one, the x plus 8 equals 7. Why is this guy considered linear? Well, if you go back up to the definition, it says a linear equation is an equation where the variable is raised to the first power. Take a look at the x. What power is that x raised to? Well, it is x to the first. We don't really write that one in. It's kind of like an invisible one, but it's there. So it is x to the first power. That's a check. Okay. Now what you have to do is you have to make sure that it's not any of the other three. Okay, so it's not allowed, the x is not allowed to occur in the denominator. It doesn't, because if I wanted to write that x as a fraction, right, that x would be over 1 right now. So that x is technically in the numerator because I could always put it over 1 if I wanted to. So it's not in the denominator, that's a good thing. Is it inside a square root symbol? No, because it would look like the square root of x, so it's not. Is it inside absolute value bars? No, it's not. Okay, so it does not, it doesn't get caught up by any of those three caveats that you have to take. So you always have to make sure that it's not in the denominator, it's not in a square root symbol, it's not in absolute value bars. And then you know if it's linear. Take a look at 3x minus 5 equals negative 22. Okay, that's plain old x raised to the first power. So it meets that condition. That's a good thing. So far it's linear. It's not in the denominator. It's not in a square root symbol, and it's not inside absolute value bar. So that's why both of these guys are linear. All right, let's look at the ones that are not linear. X squared plus 4 equals 7. All right, could you tell me why this guy is not linear? What is it about this equation that makes it not linear? And it's this dude right here. Okay, what's the deal with that guy? Well, that's the power of 2. All of the other ones on the left are raised to the power of 1. When you raise something to the power of 2, when you raise the variable to the power of 2, you get something other than a line. This is actually going to make a parabola on the graph. And you guys probably worked with parabolas in middle school. Okay, so that guy's not linear. All right, what about on the bottom? 4 over x minus 7 equals 64. Why is that guy not linear? Okay, well, the x is raised to the first power, so to speak, but the x happens to be in the denominator, and it's not, okay, it's not allowed to occur, excuse me. X is not supposed to occur in the denominator, according to the definition. Okay? When x occurs in the denominator, you get another funky graph. It's not quite a parabola, but you're going to end up getting something like this, called a hyperbola. Okay? And it's definitely curvy, and it's not linear. All right, so you should be able to identify whether or not an equation is linear or nonlinear just by looking at it, not having to graph it. Okay, here comes your practice. So as you solve for x, I want you to focus on lining things up nicely and neatly, keeping the equal signs always lined up right down the middle. You should be able to draw a dotted line through all of them, and they should line up. And you're going to work on performing inverse operations. You're going to work on simplifying and combining like terms, anything up front, if that needs to happen first. Okay, I want you to go ahead and do these by yourself. Make sure that your final equivalent equation says x equals something. Double check it by plugging it in, and know that you have all 4 right answers before we go over them. All right, go ahead and try these on your own now, and then we will reconvene to go over correct answers. Go ahead and hit pause. Okay, let's see how we did. We'll start with number 1. Negative 39 plus x equals negative 23. We are going to add 39 to get rid of the negative 39. Remember, you're not focused so much on this symbol right here. It's like, how do we get rid of negative 39? Well, we're going to add 39. And what we do to one side, we must do to the other side of the equation. And remember, that equal sign, that's kind of like midfield. Okay, that is what actually creates the two sides, the left side and the right side. All right, these guys are going to cancel out, and you're left with x equals. And notice we have an addition problem here. It's war. Positives win. They win by 16. If you plug that 16 back in for x, you're going to get a true statement. All right, let's go over to number 2. Now, in number 2, we have some simplifying to do first. Negative 17 minus negative x equals 72. Before we do anything, let's go ahead and simplify that to negative 17 plus x equals 72. That minus a negative can be simplified. All right, what are we trying to get rid of? Well, we're trying to get rid of the negative 17. To get rid of the negative 17, we're going to add 17 to both sides. And when you do this, this guy cancels out. On the left-hand side, you're left with x by himself. And then 72 plus 17 is going to be 89. You want to take that 89, plug them back in for x, and make sure that you get a true statement. Basically, you're going to get negative 17 plus 89 equals 72, and that is a war problem that ends up being true. All right, let's go over to number 3. We also have some simplification to do here. So let's go ahead and rewrite this as negative 16 plus x equals negative 7. Okay, how do I get rid of the negative 16? Well, I'm going to add 16. On the left, this cancels out. On the right, you're going to be left with a war problem. This time, in the war problem, positives win, and they win by 9. So x equals 9. And I don't know about you, but sometimes with some of these funky war problems like 7s and 16s, they don't really sit well in my head. Sometimes I get wrong answers like positive 11. If that happened to you, it's totally normal. It happens to me from time to time. It's really important that you plug this back in to make sure it makes sense. So negative 16 minus negative 9 would be negative 16 plus 9. That's a war problem where the negatives win, and they would win by negative 7. So that one checks out for me. All right, last one, and then we'll move on to some more. Here you have some simplification to do in number 4. So the negative 2 minus 12, that's type 1 subtraction that turns into get mugged twice. So you should have negative 14. You lose 2, you lose 12, you've lost 14. Negative 14 equals x plus 5. Okay, what are we trying to get rid of here? Well, we're trying to get rid of the positive 5. So I'm going to take away 5 from both sides. Left with x on the right. Negative 14 minus 5. That's get mugged twice. You lose 14, you lose 5. You have lost 19. So I hope that you got all of these right. If you didn't, that's okay. Identify your mistake now, because it's going to come back to continually haunt you throughout the rest of the year. So you want to fix this stuff up front. Okay, let's go ahead and look at some others. Now, these are trickier. Now, I'll tell you right now, you might struggle with these a little bit, but I don't want to help you. I want you to try these on your own. In some cases, you might have to simplify beforehand, but actually, numbers 5 and 6 are technically two-step equations, and I just want to see from middle school if you remember how to handle the whole negative x situation. So try them on your own. If you struggle a little bit, that's okay, but you do need to learn this before tomorrow. Go ahead and attempt these now, and then we will reconvene to go over answers. Go ahead and hit pause now. Okay, let's take a look at number 5. 12 minus x equals negative 7. What do we have to get rid of first? Well, step 1, we're going to get rid of that 12. Now, is that a positive 12 or is it a negative 12? Right now it's sitting as a positive 12. To get rid of a positive 12, we're going to take away 12. So you should be taking away 12 from both sides. And be very careful. When you do this, this negative sign comes along for the ride. So we're not just going to get x on the left-hand side. We're going to be left with negative x equals. And that's get mugged twice. You lose 7, you lose 12, you've lost 19. So we have negative x equals negative 19. And you're not done here, because we are interested in knowing what positive x is. And many of you might try to reason with this and say, well, if the opposite of x is negative 19, that means x would be positive 19. Totally true. Totally true. All right, but you have to be able to demonstrate this algebraically. So what do we do? How do we get rid of that negative sign? Okay, and you have two options. One is to divide both sides by what number? Do you remember from middle school? You're going to divide both sides by negative 1. That's just a trick that you have to have stored away. That's why this is such an important problem. Because that trick, there's probably like 10 important tricks you just need to know from Algebra 1. This is one of them. Okay, whenever you want to get rid of a negative and make it a positive, you can divide it by a negative 1. Just whatever you do to one side, you have to do the other side. Okay. The other way is to multiply each side by negative 1. So we have multipliers and we have dividers. I'm a divider. I always divide by negative 1. So a negative 1x divided by a negative 1, well, those negatives cancel out, and you're just left with x. Negative 19 divided by negative 1, that's how we mathematically produce that positive 19. Okay? And you can take that 19 and double check it by plugging it in for x. You always want to come back and plug it in. 12 minus 19 would give me negative 7, so that works out. All right, number 6 is going to be a little bit more of the same. So I would say if you didn't get these right the first time, you might want to pause again and go back and redo number 6 and make sure you know how to do this yourself. Okay? All right, what do we do? Well, we begin by taking away 6 from both sides. Very similar problem. We're left with negative x equals negative 15. Let's get mugged twice. You lose 9, you lose 6, you've lost 15. All right, I've got to get rid of that negative sign, so I'm going to divide both sides by negative 1. A negative divided by a negative is a positive. Positive x over 1 is the same as x. So x is going to equal positive 15. Just want to double check that by plugging in 15 here. 6 minus 15 would produce -9, so I like my answer. All right, let's go over here to number 7, our final problem. This one needs to be simplified first. So this minus a negative construction right here, we can simplify that to plus. So let's rewrite this as 27 plus x equals -15. All right, now what would we do? Well, we're trying to get the x by itself. We've got to get rid of the 27. It's a positive 27, so let's subtract 27. These guys are going to cancel out, and we're left with a positive x equals, and that's get mugged twice. You lose 15, you lose 27, you've lost 42. So x equals -42. Why am I not dividing this one by -1? Well, there's no negative sign to get rid of. It's just a positive x. It's exactly how we want it. I plug in that -42, make sure that it makes sense. And actually, this is a pretty confusing one to plug in. If you were to plug in a -42 here, essentially you would have 3 negatives. It'd be like saying minus -42. 3 negatives is basically the same as 1 negative. So 27 minus 42 does equal -15. And we are good to go. All right, so that's your foundation for solving equations. It probably seems pretty easy to you right now, but make sure you have this nailed down tight, because further on in the chapter it's going to get a little bit more difficult, and you have to be able to rely on your skills with one-step equations, and this just has to be automatic. All right, good job. Good luck on the assignment.